Hi everyone, this is topic 4.3 representation of reactions, and this is taken from AP Chemistry College Board. Now till now we have seen that there are different types of reactions and what is the meaning of coefficients and what are the meaning of reactants and products. Now let's see how can we actually represent those reactions in the form of particles. Now let's get started. Now, first of all, we have been studying this from the lower classes, like what is the particular representation of solids, liquids, and gases. And we already know that in the solids, the particles are closely packed together, and in liquid, there is a little bit of space between them, and they are a little bit freely moving, and in the gas they are moving apart from each other. So this is how we have been representing solid, liquid, and gas. But how do we actually represent for a chemical reaction? Same reaction I have been taking previous topic also, that what are the reactants, what are the products. So whatever we write on the left hand side of the arrow are called the reactants, on the right hand side arrow are the products. And the example which I have taken is the methane plus oxygen is giving carbon dioxide and water. Now we know that in methane the carbon is bonded to 4 hydrogens, so we will just represent carbon with different color and the hydrogens with different color circles, so that we get to know that they are the different elements. And similarly for oxygen, they are the same type of atoms, so we show it with the same colors. And in the case of carbon dioxide, it is carbon is a different element and oxygens are different and they are bonded together, so we are showing it like this. And then the water is shown like this, where the hydrogen is bonded to oxygen. Now let's see what are the things which we need to keep in mind wherever we are asked to draw the particular models of chemical equations. The first thing is that if any equation is given, you have to see that if it is balanced or not. And if it is not balanced, first of all, you need to balance that equation. The second step is to draw the reactant molecules, including their stoichiometric quantities in a reaction vessel. Now, what does that mean? Whenever you balance a reaction, you get that how many moles are basically reacting together. So you need to draw the actual number of moles in there. And then you have to draw a second vessel where you have to draw the product molecules. Also include the stoichiometric quantities here. Let's see an example here. So the question is, draw a particulate model for the equation 3H2 plus N2 is giving 2NH3. Now this thing shows that all are in gaseous form. So it means that they will be very much far apart from each other. So first step is we need to see if the reaction is balanced or not. So in this reaction we can see that it's already balanced. Now the next thing is to draw the reactant molecules. Now for the reactant molecules you can see that N2 is only 1 mole. So we will just draw 1 N2 and H2 are 3. It means that we have to draw 3 H2 molecules. Now once we are done with this, we need to draw the products. Now or for the products you can see that there are 2 NH3. Now 2 NH3 means like we will draw 1 N and 3 hydrogens bonded to it. But there are 2 moles of this, so we'll draw 2 of this NH3, and this is how we can show the particulate models of the chemical equations. Let me take another example where methane is reacting with water to give CO and H2. So can you do it first and then check the answers? So if you are done, first of all, the first step was to check that if the reaction is balanced or not. Now in this reaction, we can see that this is not balanced. So first of all, we need to balance it up. So when we balance it up, it's CH4 plus H2O gives CO plus 3H2. Now instead of H2, it's 3H2 here. Then we have to draw the reactants first. Now as it shows that there is one CH4 and there is one H2O. So we will draw that carbon is bonded to 4 hydrogens and oxygen is bonded to 2 hydrogens here in the water. Next is to draw the product. Now the product has CO and 3H2. So we will do the same thing, CO and H2, as there are 3 molecules, so we will draw 3 here. So the 3 steps you need to remember. The first thing is balancing. The second thing is you have to draw the reactant first according to the stoichiometry and then the product according to stoichiometry. If you are still confused and you are not sure that if it is correct or not, just count the number of atoms of the reactant and the product side and match them up. For example, here there is one carbon atom here, and also here there is one carbon atom. So this shows that the stoichiometry of carbon is balanced. Similarly, you can do it for other elements also. If you like this video, please subscribe to my channel and press the bell icon.